Long, long ago, about 500 million years ago, was the first episode of The Complex Power of Love, a dating competition designed to match busy proteins with their life partner. We aren't super sure about that date because the VHS eroded over time, but we are lucky that a team of archaeologists were able to dig up this treasure. In this unaired episode, we can see how myosin 2 and actin chose to be with each other and created a biochemical love that has stood the test of time.
Hello and welcome back to the complex power of love. After 9 weeks in the house, 3 proteins are left competing to see who has the best biochemistry with our lucky thin filament, actin. Let's take a trip down the memory lane for all you protein watchers who are tuning in. 9 weeks ago, our competitors made a splash with their first impressions.
Hello, I'm Actin, and I am so excited to be on this journey to make the perfect myofibril. I think the most important things I'm looking forward to doing with my future partner are taking long walks on the beach, eating spaghetti tacos, and completing my power cycle of love.
For our viewers who haven't seen actin outside of the complex power of love, allow me to explain this power cycle. The power cycle is a binding and unbinding cycle between myosin and actin that allows myosin to push itself along the thin filament, which is used in muscle contractions, cell transport, and cytokinesis.
Now let's flash back to when the competitors first started here on the complex power of love.
Hi, my name is Myosin 1, and I work in the field of vesicle transport, and I'm so excited to be here and look for the thin filament to complete my life.
Hey, I'm Myosin 2. I help with muscle contraction, and I would really like to find someone who I can bond and work well with.
Hi, my name's Kinesin. I'm an ATPase like the myosins, but my job is to carry cargo away from the cell nucleus along microtubules. I think I provide a lot of diversity in this show, so I can't believe I made it past the first episode.
Right after we finished filming the last episode, myosin 2 and actin had a secret rendezvous in the middle of the night. They snuck away to the muscle to have a private chat. Let's show you what they're up to.
Before we see myosin 2 and actin's date night, let's first get a little bit of background information on the two characters. First, let's talk about myosin 2's structure. Myosin 2 is a dimer. It's made up of a head region, a neck region, and a tail region. The tail is made up of heavy chains and is also called the rod domain. The heavy chains are 2 alpha helical sequences which form a coiled coil. The heavy chains, also called MyHC, also make up the 2 globular head regions, which are heavily conserved amongst many of the myosins, and also are important for binding ATP, and as we'll see later, actin. The 2 non-identical light chains are the regulatory and the essential light chain in the neck domain, and these regulate the activity of the head. Next, let's talk a little bit about the structure of actin. Actin is a single left-handed helix. It has 13 molecules per every 6 turns and an axial distance of 35.9 nanometers. The twist per molecule is negative 166.6 degrees, which is super close to 180 degrees. That may be why the structure looks like 2 right-handed chains that slowly turn around each other. But in reality, actin is just one single left-handed helix. Here in our game show, we have F-actin, which is the filament actin, and it's not structurally the same as G-actin, which is a monomer. Interactions in the F-actin, or the filament actin, are between the domain 4 and 3 in adjacent molecules. The D loop on the monomer is one subunit of the D loop of one subunit interacts with the domains 1 and 3 of the subunit 2 subunits down, and that's how the filament is formed. Actin filaments are formed by ATP-bound G-actin. This polymerization is energetically favorable when bound to ATP pre-hydrolysis.
You look stunning tonight. You have a better fashion sense than all of the other proteins I've seen before. It really matches my protein structure aesthetic.
Oh, thank you. Well, my fashion sense has been evolving for over 600 million years, so what can I say? What would you say is your favorite part?
I can't decide between your 2 heads, your alpha helical neck, or your coiled coil long tail. I mean, look at you. I can see why you're the most studied myosin.
I do look great, don't I? Well, I am a dimer, and I guess two is better than one. How do you like my two light chains?
Wow, they really complement your heads.
Thanks. They help to regulate my activity and how much I want to be with you. Look how pretty your filament is.
What can I say? Other filaments aren't structured to be as attractive as I am. I have to say, your heads are very alluring.
Yeah, all the actin I've been in relationships with can barely resist my heads. I guess they're a real binding site between us. Each head moves me about 10 nanometers closer to you with every stroke.
I will say that Myosin 1 does seem to have a very similar head to you, though.
Yeah, well, we're cousins, and the genes encoding for our heads are actually quite conserved through the generations. There are 20 of us in the cells.
I can definitely see that, but I promise you, you are the protein I want in my life.
Wow, that is some juicy stuff. I think we know who's going to win this competition, but we still have to see who Actin decides to pick. Will it be Myosin 1, Kinesin, or Myosin 2? Let's see who's going to get the rose.
This has been a crazy competition. I've never been away from the muscle for this long, and I'm happy to finally proclaim who my life partner will be and stay with them forever. I choose Myosin 2.
Since Actin found a beloved partner in Myosin 2, it seems like the relationship has been moving along very smoothly. In this special episode of Complex Power of Love, we witnessed a very moving ceremony of love between Actin and Myosin 2. Do you, Actin, take Myosin 2 to be your protein complex partner?
I do.
And I guess I do too.
Myosin, place the calcium ring on Actin's finger.
My dear friend of many years, Troponin, has my calcium ring. Troponin, where's my ring?
I have it right here. Just so you know, hey, Actin, if things don't work out with my girl Myosin 2, you can always just take this calcium ring off. Okay, here you go.
Oh, Troponin, you're just too funny. Well, we all know what this calcium ring means, right? Actin is off limits to everyone except me. Here you go, Actin.
That's right. This ring symbolizes my marriage and faith to you, Myosin 2.
Actin and Myosin 2, your faithfulness to each other inspires me. You may now make a bond. Through thick and thin, I wish you everlasting happiness and stability in your marriage. I think we've all truly been moved by the bond you two have developed the past 2 months. What are you going to do now that y'all are bonded for life?
We're going to work on our power stroke.
Let's talk about what Myosin 2 means by the power stroke. As always, let's look at Bob as an example. Zooming into Bob, we can see his muscle cells. Inside the muscle cells, we see Actin and Myosin 2 doing what we call the power stroke. Initially, myosin is in a tightly bound state. ADP is released from myosin, specifically the myosin head, which triggers the myosin head to bind an ATP molecule. When ATP binds to the myosin head, myosin releases the actin filament. ATP is then hydrolyzed in the myosin head, and the myosin head becomes cocked, which is at the relaxed position. Myosin can then bind to actin again, and phosphate is released from the myosin. This release of energy causes myosin to push on actin filament and be able to move alongside the filament. This is the power stroke, and it's a cycle. And so this keeps going on, at least while actin and myosin are happy.
I will provide my comforting love and binding site for Myosin 2 in our sarcomere home.
We're not the most spontaneous, so I promise that I'll be going out to get ATP every few milliseconds so that I can bind to my lovely Actin. Together, we will be such a power couple.
Aw, Myosin's commitment to our relationship moves me to the center of my sarcomere.
How are you going to maintain your relationship for the many years to come?
Well, the key to our relationship is that calcium ring. Without it, our power cycle would fall apart.
This calcium ring on my finger will prevent my many pursuers, like troponin, from trying to bond with me and wreck our marriage.
Remember, troponin is myosin 2's best friend, who handed her the calcium ring. Troponin is actually a complex of regulatory proteins that is attached to a protein called tropomyosin. Tropomyosin is attached to the actin filament. In relaxed muscles, tropomyosin blocks actin's myosin binding site, preventing muscle contraction from happening. However, when calcium is present, aka the calcium ring, calcium will bind to troponin and expose the myosin binding sites on actin, allowing muscle contraction and the power cycle to work.
It has been 6 months since Actin and Myosin 2 stabilized their bond for life, and we're all still moved by their relationship. Let's check in on the power couple and see how they're doing.
Myosin 2, you're just not the same anymore. You're all clumpy now. I'm taking off my calcium ring. It's not me, it's you.
What? Why are you blaming me? You've changed as well, and you won't let me bind to you. And you're never home anymore. And when I check your location, you're always at Troponin's house.
Listen, okay? Sometimes I get upset and take off my calcium ring, and then I somehow end up at Troponin's house. But I do want to make our relationship work. I want to be the power couple that all of our viewers love.
Yeah. You're right. You're right. I can't imagine my life without you. Let's go to a doctor and figure out what's wrong with us and why we can't move the way we used to.
Hi, I'm Dr. Fagris, and I'll be taking care of y'all today. I know how much you two want to work together, but unfortunately, I have some bad news. Myosin 2, you have a mutation in your MYHC1 chain, and Actin, you have an A289G mutation.
Doctor, what does that even mean?
Myosin 2, it means that you have myosin storage myopathy. Your cardiac beta myosin heavy chain is mutated, and that's the major component in the sarcomere. You're deteriorating because your heavier chains have started aggregating. No wonder you've been feeling weak.
See, this means that you are the problem, Myosin.
Actually, Actin, your A289G mutation means that you won't let myosin bind to you like you used to.
Let's learn a little bit more about myosin storage myopathy. Myosin storage myopathy is a rare condition that leads to formation of myosin protein clumps in certain muscle fibers, leading to muscle weakness. Other symptoms could be trouble climbing stairs, difficulty lifting the arms, trouble breathing. What causes myosin storage myopathy? The mutation is MYH7. It's a gene encoding protein known as the cardiac beta myosin heavy chain. This protein is found in cardiac and type 1 skeletal muscle. There are other mutations, typically located in the distal end of the tail, that could also lead to these issues. The effect of myosin storage myopathy is the production of the altered mutant cardiac beta myosin heavy chain, which hinders formation of the thick filaments in type 1 skeletal muscle. This leads to the formation of the protein clumps, the muscle weakness, and the other symptoms listed above. This mutation is inherited and is autosomal dominant. Let's go back to the scene and see what the doctor has to say about this.
Unfortunately, there is no cure to both of your mutations because we can't change who you are. The only thing we can do is work with your issues and offer counseling.
Why can't we work like that?
These doctors can't change who we are right now, but maybe one day.
Here are the key takeaways of our presentation. First, the metabolic role. Myosin and actin are involved in many activities in the cell, including muscle movement and cell transport. Here we focused on myosin 2 and actin, which are specifically important for muscle movement and contraction in the body. Next, the structure. The structure of myosin 2 is a dimer with a head, neck, and tail region, with light chains in the neck region and heavy chains making up the tail and head. Actin is a single helix with tight turns, even though it appears to be a double helix with loose turns. In terms of regulation, calcium binds the troponin, which causes tropomyosin to shift, revealing myosin's binding sites and allowing muscle contraction to occur once myosin binds to actin. For medical importance, the mutation is MYH7. This gene mutation results in production of altered cardiac beta myosin heavy chains, which causes interference in thick filament assembly, leading to protein aggregation in clumps.